Welcome back, everyone. In our previous discussions, we spent some time in the world of theory, exploring the abstract concept of a bag, what it is, what it's supposed to do. Well, today, we're rolling up our sleeves and getting practical. We're going to move from that abstract blueprint to building a real, concrete, working implementation. And we'll be using one of the most fundamental data structures in all of programming, the good old array. We'll see exactly how to code the ArrayBag in Java, step by step, and then we'll even build a test program to see our creation in action. Okay, this is where the theory becomes reality. Let's dive right in. So here's our game plan for today. First, we'll get into implementing the Bag ADT. Then we'll look at the core methods that make it work. We'll take a really deep dive into the trickiest one, which is the remove method. After that, we'll switch gears and see how to use our new ArrayBag. We'll build a program to test it out, and finally, we'll wrap everything up with a quick review and a little exercise for you to try. Okay, first things first, implementation. This is the part where we turn an abstract data type, our ADT, into actual, tangible working code. In the world of Java, the way we do this is by taking an interface, which is basically our abstract definition or blueprint, and creating what we call a concrete class. This concrete class is what brings that blueprint to life. Think of it this way. The bag interface is our plan. The ArrayBag class is going to be the actual structure we build from that plan. Now, this single line of code you see here is the absolute foundation of everything we're about to do. In English, what this says is, hey, we are declaring a new public class, and we're calling it ArrayBag. And with that special keyword, implements, we are making a promise, a contract really, that this class will provide the working code for every single method that's listed in the bag interface. Sinhala English may line ka hariyatanikan givisumak atsan karanawage vedak. Hitanna bag kine interface ka kianne gedaraka blueprint ka. Netam salasma. E blueprint ke kianoa me gedarato nidan kamarayak tiennone, kusyak tiennone, nana kamarayak tiennone kiyala. Habai e blueprint ke kianne ne e kamara hadanne kohomada bittiwarata mona paata ganawada durwal hai karanne kohomda kiyala. Eke තියන්නේ මොනවද තියන්න ඕනේ කියන දේ විතරයි. අනේ වගේ bag interface එක කියනවා add, remove, contains වගේ methods තියන්න ඕනේ කියලා ඒත් ඒ වගේ code එක දෙන්නේ නැහැ. Then public class ArrayBag implements bag කියන කොටසෙන් වෙන්නේ ArrayBag කියන class එක ඒ කියන්නේ අපේ මේසන් බාස් පරෝන්දු වෙනවා හරි මම අර blueprint එකේ තියෙන හැම කාමරයක්ම ඒ කියන්නේ හැම method එකක්ම හරියටම වැඩ කරන විදියට හදලා දෙනවා කියලා. එක method එකක් හරි මග හැරුණොත් උදාහරණයකට remove method එක ලියුවේ නැත්නම් Java compiler එක අපිට error එකක් දෙනවා ඔයා ගිවිසුම කැඩ කළා bag interface එකේ තියෙන remove method එක ඔයා හදලා නැහැ කියලා. ඉතින් මේ implements කියන keyword එකෙන් class එකයි interface එකයි අතරේ හරිම ශක්තිමත් සම්බන්ධයක් contract එකක් ගොඩනගනවා. Alright, so inside our ArrayBag class, we need 3 key variables, which we call member variables. We make them private to protect them from the outside world. This is a core principle of object-oriented programming called encapsulation. First up, private object array, objects equals new object 1000. This is the array itself. This is the container that will actually hold all the items in our bag. We're giving it a fixed capacity of 1,000 slots to start with. Devanua, private int size. This one is absolutely crucial. This is a counter that keeps track of how many items are actually in the bag at any given moment. This is different from the array's capacity of 1,000. The array can hold 1,000, but size tells us how many it is holding right now. Dunvanieta, private int I. This is a simple index variable. We'll use this one a bit later to help us iterate through the bag's contents when we implement the getFirst and getNext methods. Sinhala English, private object array objects equals new object 1000, kiane api baru dana rakya. Me rakya lachut 8000 axienoa. Private kiane ikin api me rakya kamariaka hulatila via letiani. Itikotapita connect to avid, make lachu hitu wakar vidida arin vinaskaran ba. Hemathemavin only class ak rules walata anua. Make it api kiana, encapsulation. Ikiane data arak shakirima. Private int size kiane harimavagavat counter ikak. Hitande, aralachu 8 api barudala tiani lacha pakavitarai. Itokoda size ik evaluika 5. Array ak capacity ik 8000 unata, atatoma items tiane kiak the kila hariatoma matika tiagane me size variable ika. Api alutin item ikak add karame, size ika 6 vanoa, ikak remove karame 4 vanoa. Antimata private int ikiane podi matika tiagani me udawak. Okay, with our variables all set up and ready to go, it's time for the fun part. It's time to actually bring this bag to life by implementing its core behaviors, the methods we promised to create. We're going to start with the most fundamental operations, adding a new item to the bag, and checking if a particular item already exists inside it. The add method is just beautiful in its simplicity. It's just 2 steps. First, object's size equals O. This line takes the new object, O, and places it into the next available slot in our array. Second, size plus plus. This line increments our counter to reflect that we now have one more item in the bag. That's it. Singaling kiwat make a haramisaralai. Size variable again hemovalema pennani ilakatatiana his slot ike index eka. Molima bagaka his, itakora size eka 0. Api apple kiana object eka add crom call croma, objects 0 equals apple, venawa. Akiani, 0 veni slot ikata apple ikat donawa. Ita pasi size plus plus line ikan size eka 1 venawa. Then size ikan pennani ilana his slot ika index 1 kielai, ava gama bagake items akok tianwa kielai. Ilagata api lemon add kurot, objects 1 equals lemon non villa size eka 2 venawa. Me vedera, size can of variable eka, parted vedadeka karanwa. Ilana his slot eka makata kianegat, bagage thanate tiana mudu items gana ki the kianegat, ikin near borne wanava. Next up is the contains method. This method's job is to answer a simple yes or no question. Is this specific object currently in the bag? To figure that out, it uses a for loop to check each item one by one up to our current size. If it finds a match, it doesn't need to look any further. It immediately stops and returns true. If the loop manages to finish without finding anything, well, that means the object isn't there, so it returns false after the loop. Singlan pehele dikorot, make it in a for int I is equals to 0, I of less than size, I plus plus kina loop ka harima vetagat. Api array ke capacity ka 1000 venekam check karanne ne, api check karanne size venekam vitarai. Mukad api dannoa, size ekin passe tiena slot sokkuma hiskiela. Eva check karla verakne. Hitanna api bag ke apple lemon grape tienua, size eka 3. Api contains lemon kiela call kernua. Loop of a patan gannoa. I eka 0 weddi, object 0 kianne, apple. Eka lemon woda samana na. I eka 1 weddi, objects 1 kianne, lemon. Annahari. Eka api hoyana object eka samanai. If condition eka true wenua. Ithanima program eka return true kiana line eka execute karla methodiking elitianua. Lupike ituru teka betakaranne na. Habe api contains orange wage nati diak helwot, lupika 012 kiana index okma checker la balanoa, magica kamwanne na. Lupika ivarovenoa. Idapase programika, lupiken pasetina return false kiana line ekara evet eka execute karanoa. Ekianne na, eka bagekinakila. These next ones are what we call simple getter methods. Their job is just to retrieve information. Get first is very straightforward. It just returns the element at the very beginning of our array, index 0. Get next is a bit more clever. It uses that internal counter I we declared earlier to walk through the bag, one item at a time, each time you call it. Critically, when it reaches the end, it returns null to signal that there are no more items. And size is the simplest of all. It just returns the current value of our size variable, telling the outside world how many items are in the bag. Sinhala English, get first sticking karanne, bag ke kena palavenima itemeka mokadda kila deneka vitarai. Get next to kinvenne, api kaling hadagata I kiana index eka use karala, ilanga itemeka denega. Api get first call karama palaveni eka levenoa, it passe get next call karana hama padama, I eka ikin barivela, ilanga itemeka levenoa. Bagake items okkuma dila evaronama, dan dinna tava items ne kila angawanna, eka null kiana vishesha value eka return karanoa. Size method ekin vinne, pitin kaura hadi ahot, bagake baru kiyak tiana wade kiela, ape size variable eke tiana agaya, ekianne item gana, elta deneka. Okay, let's take a breath because we're about to move on to the most complex method we have to implement for our ArrayBag. The adding an item was easy, right? We just tacked it on to the end. But removing an item, especially from the middle of an array, presents a really unique challenge that we need to solve carefully and efficiently. So here's the core of the problem. When you take an item out from the middle of an array, it leaves behind a hole, an empty space. Now, arrays, by their very nature, are designed to be a continuous, solid block of items. They have to be contiguous. We can't just have a random gap in the middle. So the big question for us as programmers is this. What is an efficient way to find the item we want to remove, get rid of it, and then close that gap by shifting all the elements that came after it one spot to the left? This slide gives you a look at the overall structure of our remove method. You'll notice it starts out just like the contains method, with a for loop to search for the object. The real work, the complicated part, happens inside that if block. Once we find a match at a certain index I, that's our moment. That's where we have to perform the removal. and then do the shifting. To handle the shifting part efficiently, we're going to use a very powerful built-in Java method called system.ArrayCopy. After the shift is done, we decrease the size, do a little cleanup, and then return true to signal that the removal was successful. So how do we solve our gap problem? We use system.ArrayCopy. This is a seriously powerful tool built right into Java. As you can see in the table, it takes 5 arguments, or parameters, to copy a piece of one array over to another. Now, here's the key insight, the clever trick. For our problem, we are going to use it to copy a part of our objects array back onto itself, just slightly offset. That's how we'll perform the shift. You might ask, why not just write our own for loop to do the shifting? The reason is pure efficiency. System.ArrayCopy is not regular Java code. It's a highly optimized, low-level system call that moves blocks of memory around much, much faster than a standard Java loop ever could. Sinhala kivot system.ArrayCopy kiane, arrayika kodisek ikatanaking, tawatanakata copy karana pavichikarana harima wigawat, vishesha function ikak. Makata details pahakde none. 1. src, source, copy karana one mona array iganda. 2. scr cos, source position. A array ika, kiane tene indan copy karana patangane. 3. Destination, copy karala alavana one mona array ikatada. 4. Dest pos, destination position. A destination arrayika, kiana tene indan alavana patangane. 5. Length, elements kia copy karano oneda. Api visheshatwe tamai, api source saha destination dekatama api objects array ekama pavichi kalaneka. Eka haryata poteka panahavani pitue indan, thienatika copy kirla, hatalisnavani pitue indan paste karano wagewarak. And this line of code right here is where that magic happens. This is the implementation. Let's break it down piece by piece, connecting it back to the table. The source array is objects. The source position, SRPS, is I+1. This means we start copying from the element that comes right after the one we want to remove. The destination array, dest, is also objects. We're copying onto the same array. The destination position, destPos, is I. We start pasting right on top of the item we're trying to remove, effectively overwriting it. And finally, the length, size minus I minus 1, is a calculation that gives us the exact number of elements that are left in the array that need to be shifted over. May code line again tamai ara shifting magic agawinne. Hitanna api I wanithana in the item ika remove karanawa. Itagoda I+1 idan antimo vinakam thina okkumatega copy karagana. I wanithana idan isarahara paste karanawa. Akim winne, I wanithana tibapana item eka replace wala. Ida pasta tiba items okkuma eka sladakak isarahara enwa. Ara histana gapika netivalayanoa. Let's really visualize this to make it sink in. Step 1, we start with an array of 4 fruits. Step 2, our code loops and finds orange at index I equals 1. Step 3, this is where array copy kicks in. It takes everything from index I+1, that's index 2, onwards, so lemon and avocado, and it shifts them one spot to the left, pasting them starting at index I, index 1. Step 4, for a brief moment, the array looks like this: apple, lemon, avocado, avocado. We've overwritten orange, but now we have a duplicate avocado at the end. Step 5, to fix this, we first decrement the size to 3. Then we set the now unused last slot, which still holds that duplicate avocado, to null. This is good practice to help Java's garbage collector reclaim that memory. Step 6, and there we have it. The final clean array is apple, lemon, avocado, with the gap perfectly closed.
Sinhalen hittuwot මේක හරියට සිනමා ශාලාවක පුටු පේලියක් වගේ. පේලිය මැදින් කෙනෙක් නැගිටලා ගියාම එතන හිස් පුටුවක් ඉතිරි වෙනවා. එතකොට එයාට පස්සෙන් හිටපු හැමෝම එක පුටුවක් ඉස්සරහට එනවා. ඒ හිස් තැන පුරවන්න. system.arrayCopy එකෙන් කරන්නේ අනේ shifting එක එකපාරට හරිම වේගවත්ව කරන එක. ඊට පස්සේ අපි size එක අඩු කරලා අන්තිම පුටුවේ දැන් කවුරුත් නැති නිසා duplicate වෙලා තිබ්බ කෙනත් ඉස්සරහට ගියා නිසා ඒ අන්තිම slot එක null කරලා ඒ කියන්නේ මේක දැන් හිස් කියලා සලකුණු කරලා තියෙනවා.
Okay, we've done the really hard work. We have designed and built the ArrayBag class. Now, let's switch hats. We're going to stop thinking like the person who built the ArrayBag. Now, we are a client. We're a developer who has a different problem to solve, and we just want to use this new data structure in our program. This single line of code is one of the most important concepts in object-oriented design. Bag of fruits equals new ArrayBag. Notice how our variable, bag of fruits, has the type bag, the interface, not ArrayBag, the concrete class. This is called coding to an interface. It means our bag of fruits variable only knows about the public methods defined in the bag interface, like add and remove. It is completely unaware of the internal array, the size variable, or the shifting logic. This makes our code incredibly flexible and powerful.
සිංහලෙන් කිව්වොත් මේක හරිම වැදගත් concept එකක්. අපේ bag of fruits කියන variable එක හරියට TV remote එකක් වගේ. ඒ remote එකට ඕනෙම Sony TV එකක් control කරන්න පුළුවන්. ඒක දන්නේ on off, volume up down, channel change වගේ standard buttons ටික විතරයි. ඒ TV එක ඇතුලේ LED ද LCD ද tube එකක්ද තියන්නේ කියලා remote එක දන්නේ නැහැ, දැනගන්න අවශ්‍යත් නැහැ. අන්න ඒ වගේ bag of fruits variable එක දන්නේ bag interface එකේ තියෙන add, remove වගේ public methods විතරයි. ඒක ඇත්තටම array bag එකක්ද නැත්නම් අනාගතයේදී අපි හදන linked bag කියන වෙන class එකක්ද කියන එකකට අදාළ නැහැ. මේ නිසා අනාගතයේදී array bag එකට වඩා හොඳ linked bag කියන අලුත් class එකක් හැදුවොත් අපිට මේ line එකේ new array bag එක කියන එක new linked bag එක කියලා වෙනස් කරන්න විතරයි තියෙන්නේ. අපේ program එකේ අනිත් code එකේ එකම line එකක්වත් වෙනස් කරන්නේ නැතුව program එක run කරන්න පුළුවන්. ඒක තමයි මේ ක්‍රමයේ තියෙන ලොකුම වාසිය.
And once we have our bag of fruits object, look how simple and intuitive it is to use. We can call .addApple and .addLemon to populate it. We can then ask it questions with .containsLemon, which correctly returns true, and .containsOrange, which correctly returns false. And calling .getFirst will, just as we expect, return apple. As a client, we are simply using the public interface we defined. We don't need to know how it works, just that it works. So we've built our class, and we've used it a little bit, and we think it works correctly. But in professional software engineering, we never just think something works. We don't assume, we verify. And to do that properly, we need to build a separate test program, sometimes called a test driver. The one and only job of this program is to create an instance of our ArrayBag and put it through its paces, rigorously testing every single method to ensure it behaves exactly as we expect it to in all situations. So to do our testing, we create a completely new class. We'll call it Bag ADT. This class will contain our special main method, which, as you know, is the entry point for any Java program. Inside this main method, the very first thing we'll do is create our ArrayBag instance, and then we'll add a whole variety of fruits to it so we have some interesting data to work with for our tests. Now, as part of our test program, we're going to write 2 new helper methods to make our testing easier. Now, it is extremely important to understand that these methods are not part of the ArrayBag class itself. They are client methods. They live in our Bag ADT class, and they use a bag object. The first, printBag, will simply display all the contents of any given bag. The second, removeAll, will give us a new capability, the ability to remove every single instance of a particular object from the bag. This removeAll method is just a beautiful example of building new functionality on top of existing code. It's all about code reusability. It cleverly uses the remove method that we already built, but it puts it inside a while loop. Now, think about it. Our remove method was designed to return true on a successful removal and false if it couldn't find the item. The while loop simply keeps calling b.removeO over and over again. As long as it succeeds and returns true, the loop continues. The very moment it fails to find the object and returns false, the loop condition becomes false and the loop stops. By then, all instances are gone. Singaling kiwat mekarim expanu vidihak. Api aluten item hono logic ekak liyanno ne. Api denetamat hadapu remove method ekak pawichi karanoa. Hitanna bag eke apple tunak tienoa. Remove all bag apple call karama while b.removeApple vera karanoa. Paravina remove eka successful, true return karanoa, loop eka duanoa. Devini remove ekat successful, true return karanoa, loop eka ayat duanoa. Tumwani ekat successful, true return karanoa, loop ekat hava parak duanoa. Then bag eka apple ne. Hataraveni para remove apple call karadi, eka false return karanoa. Itakuta while false kena condition eka fail vala, loop eka natarwenoa. So, it is absolutely crucial that you understand the distinction here, as shown in this table. ArrayBag.remove is a core method. It lives inside the data structure itself. Its job is very specific. Find and remove only the first matching object it encounters. Bag ADT.removeAll, on the other hand, is a client method. It lives outside the data structure in our test program. It uses the public interface of the bag. Specifically, it calls the remove method repeatedly inside a loop to achieve a more complex, high-level goal, removing all matching objects. This is a fundamental concept in software design, building powerful tools by combining simpler ones. All right, we have covered a lot of ground today. We've gone all the way from abstract theory to a concrete implementation and finally to testing that implementation. So let's start to wrap this up by reviewing the key takeaways from this entire process. These are the points you'll really want to remember for your exams, and then I'll leave you with a small challenge to tackle on your own. So what are the key concepts that you really need to take away from this? First, how to implement a Java interface to create a concrete class. That's the whole blueprint to building idea. Second, the internal array-based logic for the add, contains, and especially the remove methods. Third, the function and parameters of system.arrayCopy. You should definitely remember what it does and why it's used for efficient element shifting. Fourth, the importance of writing a separate test program to verify that your code actually works as intended. And finally, that crucial conceptual difference between a data structure's core, internal methods, and the external client methods that use its public interface to get work done. These are all fundamental concepts in data structures and algorithms. And now for your exercise. This is a very common style of question you might see on an exam. Take the remove all method we just wrote. Can you modify it so that instead of returning void, nothing, it returns an int that represents the total number of items that were successfully removed? Think about it. What would you need to add inside or before that while loop to keep a running count? I encourage you to pause the explainer right here, grab a piece of paper or open an editor, and see what you can come up with. It only takes 2 small changes to the code.
And that officially brings us to the end of our ArrayBag implementation journey. A great real-world example to remember this by is a shopping cart on an e-commerce website. You can add items, duplicates are allowed, you can have 2 of the same book, and the order you added them in doesn't really matter. That's a bag. Today, we used an array to build our bag. But as we know, arrays have limitations, like their fixed size. In our next explainer, we're going to dive deeper into arrays and then introduce a completely different and very powerful way to store collections of data called a linked list, which solves some of the array's problems. Thank you so much for watching, and I'll see you in the next one.